Ladies and gentlemen, welcome back to another live stream. So in this live stream, we're gonna teach you some C programming language. Of course, this is part 2. So part 1 was yesterday. I have covered some fundamentals of the C programming language. Please go check it out. Otherwise, today we're probably gonna be using Raylib and try to show you how you can make some simple video games using the C programming language. And of course we're gonna, or should I say, I'm gonna teach you the rest of the stuff that we're gonna need along the way, just to make it a little bit more fun, you know. So yeah. Alright, let me share the stream. Okay. On my Discord server, please join my Discord server. You can find the link down in the description below. Alright, so everyone, live part 2. Okay, perfect. So I guess let's get started. So I haven't, and hello Loop Luminary, welcome back to the live stream. How is it going, mate? So okay, that was an expected message. Anyways, oh my god. How the heck do I hit the same message? Crazy stuff. Hold on a second. I don't know what he's gonna say. So hold on just a second, please. Oh boy. Well. Let's see, app settings. Perfect timing, huh? Well, I guess I'm just gonna install WhatsApp from my computer for now. I don't know how to disable notifications apparently. Anyways, let's get back into it. I'm sorry. Alright, display capture. Okay. So as I said, we're going to be trying to use some Raylib. I'm going to try to teach you how to make some simple video games in the C programming language, and I'm going to teach you the rest along the way. Now the problem is I haven't touched Raylib for a long time now. I usually use game engines to... Hold on, did I actually enable... Yeah, I did. Alright. I haven't used Raylib for a long time now. I usually use game engines or even make my own game engine from scratch if I want to make a video game, and that's pretty much the recommended way if you really want to make like a complex video game. But since we're learning C, I'm basically using, you know, video games as a fun way to learn C essentially. But it doesn't actually matter because that's good. So you can actually see me how I'm gonna, you know, navigate Raylib myself as an advanced programmer, because that's really what you need to learn. If anything you need to learn from these live streams that I'm teaching you about the C programming language or the programming in general is how do you solve like problems that came up, and also how to search for the information that you need. It's like that's the most important skills when it comes to programming. And of course debugging. Yeah, debugging, so well, you could find problems. Anyways, whoa, G Giron, welcome back to the live stream. Alaikum salam. Oh yeah, Robert, the big G is live. Thank you, Robert. Welcome back to the live stream. So, I mean, it's midnight, so it's perfect timing for me. Anyways, let's go to Raylib, and the first thing that I need to teach you about is how to install libraries. Now, I remember, well, hold on, let me grab the chat real quick. Oh, I haven't yet done that. Alright, hold on. Let me go to, oops, what the heck? Okay, pop out the chat. There we go, perfect. Now let's grab this chat here and put it there. Perfect. Alright, so as I said, the first thing that I have to teach you about to actually make a video game here using Raylib is how to install libraries. I haven't actually covered that in the last video or the last stream. So let's find out how. And we don't need this code anymore, so we could just all remove it. And let's go. Oops, I can't apparently. Alright. Well, whichever. Let's remove this code 2. Oopsies. Well, let me just use the mouse. Oh my god. Alrighty. And yeah, this is good enough. Alright, so back to level 0. Okay, so let's find out how we could do that. Alright, let's go to Raylib here. Raylib, let's search for it, right? And here we go. This is the official website of Raylib. And I'm just gonna go, so like you can find here the about, the examples, some games that are made using Raylib, in C of course. It's all code pretty much. Raylib is just a library, it's not a game engine, so it doesn't have an editor. But yeah, and there's also a cheat sheet, which would also be helpful for you as a beginner too. Alright, so let's get going. Alright, let's go to the GitHub repo here so we can install it, or maybe there's another way. Let me check out. It's been a long time since I've used Raylib. And apparently there's a download now here. I do remember they had some not IDE, but like Notepad pre-configured before. But yeah, you could use it on a lot of sorts of languages like Rust, my favorite programming language, Python, Lua, Go, C#, Zig, Odin, you name it. Like, that's the nice thing about C libraries, is that they're very compatible with any other language, because C is usually like being the mother of all programming languages, right? It's used to do the, what is it called? To do the communication between two languages, especially the compiled ones. But anyways, all right, so let's go to see, if I click on download now here, what's gonna happen? You could donate. For now, we're just gonna say no thanks. And yeah, it would basically install some stuff. Let me see what it's gonna do. As an advanced programmer, what I would usually do is just to go to GitHub here, right? Yeah, I already done that here. And then go to releases. That's how you would usually go about finding the library binaries. So here, Raylib 5.5, okay. Now you go down, 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 down. Oh boy. And here we go. You're gonna find some assets here. Now, what my platform is Windows, so I gotta look for Windows, right? So Win here. And I have a 64-bit computer. Well, most of the computers today are actually 64-bit, not 32-bit. That list of names is almost as long as your big. Oh my god. Well, alright. So let's see how we could find like the bit width of my computer. So I just go to properties here. There we go. And where is it? Okay, as you can see, system type here is 64-bit operating system x64 based processor. So it's 64-bit. So I need Win64 apparently. Now I have other options in Win64 apparently. I have MinGW and I have MSVC. Now currently I'm using Visual Studio, which means I'm using the MSVC compiler, so I'm gonna go with that one. Save. I think that Raylib installer would probably have some easier ways for beginners to approach this. But this is like not, most libraries wouldn't actually give you a helper installer and so on for libraries. Most libraries, you would go to their GitHub repo, you would check the releases, and then get your binaries from here. And in fact, some libraries, you wouldn't even have the binaries like that you could link to your program. You actually only have the source code and you have to build it yourself, then use it. But you as a beginner, for now, I may actually try to make a tutorial about that later on, or in a next stream in the same series. But anyways, let's see run anyways. Oh yeah. Hopefully I don't get hacked today. Let's see. Oh boy. What happened? No. What happened? I just gave it like the permission and nothing happened. So I guess time to check. Oopsies. I need to check out my task manager here. Okay, finally. Oh my god, that took too long. That's enough time to copy my whole system. Anyways, so install path C Raylib. Okay, let me see what it's gonna do. Install. And then apparently it's doing. By the way, this application is actually made by Raylib itself, so it doesn't have to be a video game. Like it could be just like a regular application, like let's say image viewer. I actually made an image viewer before using the Zig programming language in this channel, using Raylib. Hello, just started learning C and I want to work on embedded systems in the future. I found your channel quite interesting. Thank you, Fenzel Romanizi. Thank you for the feedback and welcome to the live stream. Which videos you have found my channel on? So Raylib installed successfully. Okay, let me see what this have installed exactly. Close. Okay, why this doesn't work? Oh, all right. Let me see what it done. So disk C. Okay, so it installed this Raylib folder. Okay, I guess maybe this is the source code. Yeah, and is there the binaries here? MSDK, NNPP. This is a compiler. This is another compiler called W60. Well, it's not really a compiler, but I think it's a compiler kit, which kind of makes it easier, I believe. But anyway, that's not. But basically here, they give you, as a beginner, you don't have to actually have like a development environment like Visual Studio. You could just go here and click on this Notepad++, and then it would actually have, like you would have the, oh my god, that's too bright. Oh boy. Well, one thing about programmers like me, or like Batmans, you know, we hate light. Anyways, so where can I find it? Like, oh my god, edit. My eyes, boy. My eyes, my eyes. Where is it? Preferences, okay. Well, I guess I guess that's one thing you should learn. A very important skill about programming is that you need to learn how to how to find dark mode. Because you'll be sitting on your computer like for a very long time, so you'd better use the dark mode. Anyways, the dark side. Alrighty. Okay, so basically that launches an IDE. Well, this is not a very like what can I say? A very sophisticated IDE, but I guess it could do the job for you as a beginner if you want. And with this, actually, you don't even need a development environment like, as I said, Visual Studio, MSVC, compiler, etc., because it's all included inside of its Raylib folder. Like the compiler is actually here. This is the W64 div kit. And then Raylib is here and some MSDK thing. I guess this is probably for the web, to export your game to the web. But anyway, let me see how we could actually run this code using this. All right, I guess run maybe? The program to run. Huh. Let me see the instructions of this installer. Let me see the instructions of this, where they are. Huh, there is no instructions? Are you kidding me? Oh, hold on. Maybe this is it. To test the example, just press F6 and execute Raylib. Compile it. Okay, cool. So F6. Oh boy. Do you play games, Codotaku? Well, I used to play games. And that's in fact why I actually entered into the programming sector. Because I enjoyed playing games, and so I wanted to create my own game. I was curious on how games were created. So that's how I started, right? But now, unfortunately, I'm 21 years old and I don't enjoy playing games anymore. But I'm still stuck being game developer, so I still have to make games. Though, like, that's why I actually have delved more into, you know, systems programming and creating a game engine and like the technology behind that stuff instead of games themselves, right? You start out with Rust, you ended up with no, I started with Roblox Lua scripting language, and yeah, started there because I was too young at that point. I was playing, like, the first game I remember I played Lumber Tycoon 2 there, and I really loved it, and somehow I ended up realizing that that game is made by someone who's just like me, a human being, not an evil corporation, right? Using a software application that is actually already installed in my system, Roblox Studio. So, and that's where it all started. All right, so I have pressed F6, and now I'm gonna say okay, and let's see what's gonna happen. Okay, so it's doing some stuff here. It's using GCC, as you can see, to compile that thing. And there we go. So it works. So you don't actually need a compiler and development environment if you want to use Raylib. You could just use this Notepad++. Though, as I said, it's not very sophisticated, but it should get your job done. But for me, I'm not a beginner, so I'm just going to use my development environment, and honestly, I would recommend you to do that too, if you're serious enough. So yeah, anyways, so let's see what we got from MS. Okay, so this is the thing that we have installed from GitHub here. Let's actually extract it. Extract all, extract, and let's see what we got here. Now, the problem with the C++ and C libraries is that there's not a lot of conventions on build systems and so on. So, like, you just gotta figure it out yourself a lot of the times. Though, usually you would find it something similar to this. You would have like a lib folder, right, where you have your libraries that you can link to. And then you also have your include folder, which have some headers that you can include into your code. All right, so that's perfect. So how I'm gonna use this? Well, I'm gonna open up here. I'm gonna right click on my project here, sorry, and then I'm gonna go to, where is it, open folder in File Explorer. And now this is the folder of my project, as you can see. Now I'm just gonna copy these files there. Now, as an advanced programmer, I don't really do this manually like this. I actually use CMake, a built-in system. But that's for, I guess, for another video. But right now I'm just gonna do this stuff manually. So let me just Control V to paste this stuff, and there we go. So now I have these in my thing, right? Now let me actually just steal some code from Raylib examples, because that's how you learn any new library. And by the way, one note is that, like in university, for example, what you're gonna learn about programming is that you're just gonna implement a lot of algorithms and stuff. You're gonna be forced to do that, though most of the time as a programmer you don't really implement algorithms yourself, at least not the popular ones, you know. So like, for example, I don't know, oh my god, I can't think of like graphs, you know, and algorithms. What is it called? Oh my god, like bubble sort and all those algorithms. You don't implement them yourself. Like you most of the time you just use a library that is out there, unless if you didn't find any library that does what you want to do basically, and so on. But anyways, let's not waste some time on this. Let's go to the examples right now. And let's copy some example here. Let's start with this basic window here. All right, and let me just steal this code. Oh boy, let's go. What the heck did I do? All right, so copy this and paste it here. All right, and now we have a lot of errors. So first of all, cannot resolve symbol init window, because as I've shown you before in the previous stream, it doesn't know this symbol. It needs to be defined, right, somehow. And this is from the Raylib library, which we didn't include yet. So right now it doesn't know what that means, what clear background means, and so on. Also, we have raylib.h here, which it cannot find. It cannot open source file raylib.h. That's called the header file. All right, so how we could actually right now install Raylib? Let's find out. So let's go to properties, I think, yeah. And now let's go to VC++ directories. Now, of course, this would change depending on which IDE you're using, but if you're using Visual Studio, this is how you do it. If you're using another IDE, you could just search up Google, like on how to actually install libraries using that IDE, right? Anyways, so here we got include directories. I could open this. And by the way, before we do that, let's make sure to go configuration here. Now there is a debug configuration and release. Debug includes a lot of stuff into the binary, so it's kind of bigger and also a bit slower, but it does give you more information to debug your program, to find out problems, etc., and it's not really that optimized. So like you can't have both at the same time. But for now, we're just gonna say all configurations, meaning either if it's debug or release, we don't care. We still want to configure the same configuration. So I'm gonna say all configurations. Same thing with platform, although it doesn't really matter that much here. But anyways, so let's go include directories here. And let's go here and let's add this include folder. Select folder, okay, and there we go. Now we should resolve one problem, which is that right now I can actually find this Raylib header file. This is the whole Raylib library. Well, not the whole thing, right? But the header, basically, the main header of Raylib, all here. So right now I could find it because I told it where to find it. I give it that include folder that contains raylib.h. So now we're done with this piece of the puzzle, right? Now what is the next piece of the puzzle? Let's see. It should actually be declared by this point, huh? That's interesting. Oh, there you go. So the idea was just a bit slower there. All right, fine. So right now, we don't have those errors anymore of like, you know, having to define those functions and so on. Right now, they are defined and they're defined in this raylib.h file. For example, if you hold control over init window here and you click on it, you're going to find that it's defined here. This is the declaration of this function. It contains this RLAPI macro. You could just ignore this for now. And the void basically does not return anything, and it takes 3 arguments. It takes the width, the height, and the title. And here it says what you could use that function for: initialize window and OpenGL context. So yeah. Now let's actually try run this program and see what happens. Oh boy. Okay. So now we have another kind of errors in resolved external symbol. What the heck? I'm not sure why it keeps on changing the errors. But anyways, in resolved external symbol, meaning that yes, this is declared, but it couldn't find the implementation. It did find the declaration of the function, which is here in this header file, because the header files usually only contain the declaration of stuff. But right now, to find the implementation, we need to give it the actual libraries, or implement them ourselves, like by actually saying that void init window. Okay, let's see, void init window, and then, or basically go in here, right? And we're gonna copy this declaration, right? And then I could like implement it myself and do whatever I want. But that's not exactly what we need here. We want to actually use Raylib itself. So let's actually do that. Right now, let's link these libraries. So here you're gonna find library directories. So you're gonna add it there. Gonna add lib here. Though hold on, let me see what that exactly contains. Okay, lib. All right, so as you can see, it contains the DLL and the lib. All right, perfect. So let's go to lib here. and select the folder, and we're going to add it to library directories. So basically we're telling it where it can find libraries. Now if we say okay and we try run this, we're still going to have the same exact problems, because yes, we told it where to find other libraries, but we didn't tell it which ones to link in those folders that we added. So now I need to go to linker input and then additional dependencies, edit. And then here I need to get the names of those dependencies. In my case, it's Raylib. I don't remember if it's raylib.dll or .lib. Probably .lib, I would guess, but let's see. No, probably not. So maybe then .lib, I don't remember. Because I don't usually use this way to actually include dependencies. I use CMake. But let's see now. Huh. Now those errors actually been gone. But now we have another problem apparently. What? Impl time begin period reference in function init platform. I'm not sure what the heck is wrong with this. Raylib DLL. Let me try some other names. Raylib DLL. Apply. Raylib DLL was not found. Interesting. So maybe I need right now to actually give it, like to basically show it where it can find the DLLs. So I guess maybe then, hold on a second. How to add DLL holder in, oopsies, what the heck, in Visual Studio. And let's see. That's very strange. Okay, let's just look for a tutorial then. How to install Raylib in Visual Studio. Windows moment. Yeah, pretty much Visual Studio. Should probably just use CMake. But anyways, let's see. Someone is using VCPKG. Has Nugget. Oh yeah, there's also another way actually to install it in Visual Studio that I just remembered, which is called Nugget. I'm gonna show you that way too. But let me try to get this to work this way first. Should be the same way. Set it up for C. Okay. And add to additional dependencies. Raylib.lib. raylib.dll.lib for dynamic linking, but it's saying that it couldn't find the DLL, so I need to find some way to do that. How to add the DLL? Directory in Visual Studio. Let's see. Did I set the path to DLL? No. Let me try to actually ask the AI and see what it's gonna do here, if it's gonna be any useful. How do I add an additional, well, hold on, additional directory where Visual Studio can find DLLs? Okay, let's see. To add an additional directory where Visual Studio can find DLLs, you need to modify the environment settings for your project. Here are the steps to do this. Open project properties, right click on your project in the Solution Explorer, select properties, navigate to debugging settings. In the project properties window, go to the configuration properties section, select debugging, modify environment in the debugging section, find the environment field, add the path to your DLL directory to the path environment variable, for example. That's interesting. I don't think it should be that hard. I'm not sure what I'm missing here, but let's try this solution. So basically, we go to here and say properties. I think debugging, there we go. And then path environment, basically, I guess. Yeah, environment edit. And then path is equal to path. And then I need to add this, I guess. Is that the case? Probably. Let's try this now. I mean, it works. It's a very strange solution. I've never even done this before. I'm not sure why it didn't work the regular way. But here we go. It actually works. I basically added that path of DLLs to my environment, but yeah. There we go, it actually works. Though there is a way easier way to set up this. Actually, you don't have to actually do all of this, well, at least not most of the time. So I could just remove those. So let's just remove this stuff that I just added right now and show you other ways to actually set up libraries. So I'm gonna remove this, and I'm gonna remove library directories. There we go. Okay. So as you can see, like adding libraries in C and C++ is not that easy. I remember like being a beginner, I lost hair, a lot of hair on this process, especially with CMake. But anyways, all right. So linker input, and I also don't need this. All right, so basically just like what we had before, right? And we don't need these either. Well, hold on. Let's go to open folder and file explorer, and we don't need these include in lib anymore. Now here's the second way, and here's the recommended way in Visual Studio. If you can find a library, because sometimes you can't find it using this way, but like if you right click here, right, and say manage NuGet packages. I actually forgot about this way of doing it until I've seen that comment which reminded me, like in Reddit, right? But anyways, you search here for any library you want. If you find it, great. You don't have to do any of that crap, right, that we have done manually. If you don't find it, then you have to do that. Right, so let's search for Raylib. Raylib is a very popular library in all sorts of languages, so you're surely gonna find it. And there we go. So this is the first one, though this is just 17.4K doloids apparently. Oh, so this is Raylib 5, and this is Raylib 6.11, and it also have a lot more doloids. This one is for C# apparently. So you're just gonna be careful with which one you choose, but this seems to be the one, I guess. So let's install this. Oh, hold on, Raylib. Oh, hold on, cancel. This is a C# binding. Oh my god, what the heck? So then maybe this then. That's strange, and this one only contains stable version. Well, I guess then let's just go with it anyways. I'm not sure, but apply. And if this works as expected, we should be able to use Raylib directly without any of that setup. Boom, there we go. It just works. That's pretty sick. Though, hold on. I also want to remove that thing that I've added about the environment thing, right? We don't need that anymore either. Oops, let's see. Why can't I remove this stuff? What the heck? Oh, that's the evaluated value. Okay. All right, apply. Okay, perfect. Let me make sure this still works. And yeah. All right, so that was a bit about how to install libraries. There's another way that I haven't covered here, which is CMake. But we don't need that for now, maybe in another live stream or something like that. But anyways, let's go back right now to Raylib. So right now everything works, and you could even see the actual documentation of the function. Like for example, here in init window, it tells you exactly what this does. So initialize window and OpenGL context. Now let's go through this line by line and see what happens. So let's actually even use the debugger, because why not? That's fun, I guess. And yeah. Let's actually use the debugger, and I basically put a breakpoint here, and let's go, man. So the screen width, so here we're basically creating two integer variables, screen width and screen height, which would of course basically represent our window dimensions, like the width and the height of the window in pixels, right? So let's go to the next step. Now here we got init window. So this init window function, it needs 4 arguments. The first argument is the width of the window that you want to initialize here. And the second one is the height. The third one is the title as a string, right? And so in this case, we're just using these variables, or should I say constants here. So yeah, though we could have just said 800 directly and 450 here directly. And look, we actually got like a window show up right now. Already, which is great. The next function is setTargetFPS. FPS stands for frame per second. It's basically how much images you want to draw every second. Because the thing is, a video is just an illusion. A video is just like a lot of images every second. So in this case, it would be 60 images per second. And you basically see those images because they move, like they change too fast. You see them as a video, right? But actually there's nothing called a video. But anyways, let's go straight to the point now to target FPS. Now here we got a game loop, or yeah, main game loop. And then afterwards we got the close window. Basically we kind of deinitialize and close the window, pretty much. Nothing to explain about there. Anyways, let's go back to the main loop here. So we got while not. So while, this is basically not operator. So it basically takes this function here. It gives us back a Boolean value, right? An integer, either 0 or 1. So if it's false, then it's 0. If it's 1, then it's true, right? And not basically invert that. If window should close is true, then not window should close would be false, and the reverse is also true. But anyway, so detect window close button or escape key. So if it while not window should close, so while not the window is wanting to close by the user, then we're gonna rerun this function, this stuff here, right? So the first thing is the update stuff, and then the first thing is begin drawing function. So you basically call this before you can use any drawing functions here. And then you got clear background. And of course here we're passing a color. And this one is just a constant color, though you could use any color on RGBA values. You could search that up. But basically, when it comes to the pixels on your screen, like every pixel have a color, right? And how we represent those colors, like every pixel have 3 kinds of lights, right? They have like a red light, a blue light, and a green light. And depending on how you mix those lights, you get a different color, right? So like if you only like run the red light, of course you're gonna get a red color. If you, let's say, run the red light and the green light, then you're gonna get yellow, and so on. And of course you can also change the intensity of those lights to get different colors. So, and walaikum salam salim, welcome to the live stream. All right, so that's clear background, and then we have a draw text function. We're calling it and we're giving it this text. Congrats, you created your first window. So that's basically the first argument of this function, is what kind of text we want to draw into the screen, or should I say the window. And then here the position in the X and the Y.
of course in Cartesian coordinates of the window, and the window Cartesian coordinates are starting from the top left corner, so there's 0 0 here, and on the right, well, top right, it would be like maximum x value, like the width, comma 0 in the y-axis, and so on. That, yeah. All right, cool. And we also have the font size here, which is 20 in this case. You could change it to whatever you want, of course. And finally, the color of the text. And oh my god, I'm not sure what happened to my mouse. What the heck? What in the world is happening here? Oh, it's just my pen right here. I was like, what the heck? All right, is the stream still fine? Seems like it. Anyways, perfect. And then finally we say end drawing. So anything that begins should also end. And yeah, that's basically it. Let's actually see what happens here. So while that window should close, then we begin the drawing. And then we clear the background. We draw the text. We end the drawing. And then we go back again. While that window should close, we begin the drawing. So now every time this game loop reruns, we're basically making a new frame. We're drawing a new image. One of the images of those 60 frames or 60 images, right? So every second, this while loop right here would run like 60 times every second. So yeah, that's basically it. And it's just gonna keep on going like that until you try to close the window. But I can't really close it. Maybe I could do it like that. Let's see. Yeah, there you go. So I tried to close it, and right now I'm just gonna close the window. And boom, that's it, done. All right, so now let's actually make something more interesting, I guess. Now, as I said, you don't really need to actually make these into variables. You could just inline them, you know, like this. But it's great because you may want to use those, like the width and the height of the window, in your calculations later on. And let me just remove these kind of comments because they're annoying. There's just a lot of stuff here. I just remove them. Comments are useless. Just joking. All right, but how do they set an upper limit to frame rate? Do they use a timer? I'm not sure. That's the nice thing about a library or a function in general, is that they're black boxes. You don't really know exactly how they're implemented. They just work. You just call them with certain like values, and then they return some other values, or they do apply some effect into your computer state, right? But you could actually check it out. Like, we can check it out, of course, in the source code. And I mean, I don't think that's a good timing to actually try to do that, but maybe I could see. Let's see if I can do that, I guess. Really, GitHub. Maybe I can show you how to read the source code for Raylib here. Anyways, let's see. I'm not sure if I contributed before to Raylib. Probably did in my previous account. But anyways, so let's search for something. Oops, see what I've done there. Let's search for something here. Let's search for set target FPS. And we have a C file, a header file. So header file only contains the declaration. The C file would contain the actual implementation of this. There we go. And this is basically the implementation of this set target FPS in Raylib. So it checks, first of all, if FPS is less than 1. Though actually, hold on a second. I may be able to actually do that here. I don't think though, because we're using the DLL here. Yeah, we're using DLL, so probably not. So it would probably just go into actual assembly code because we're using a binary. Yeah, I can't, in fact. It doesn't even show the assembly code, apparently. Alright, anyways. So let's go back here. So we're checking if FPS is less than 1. If it's less than 1, then we're setting the core.time.target to 0. Else, core.time.target is equal to 1 divided by FPS. Right? And then trace log. Okay, so core.time.target. So where this time is being done, it's here. So this is the time struct, apparently. But yeah, I'm probably just gonna confuse a lot of people if I go any further than this. So yeah, let's go back to the thing. All right. So perfect. So what we want to do right now, begin drawing, clear background. Okay, let me see what we have here. Right? Well, let's actually also remove this comment right here. And yeah, that's basically it. What's wrong with you? Does not match. Okay, fine. Let's rename. And I'm basically saying control dot to actually apply this suggested change. And let's just run this. Perfect. Read a blog about game loop a while back and it was trickier than I thought. Yeah, it is, but as long as you're using Raylib, it shouldn't be hard. Yeah. Alright, so here we got just a basic window that have 800 pixels in the width and 450 in the height. And it runs 60 times per second. And it clears the background with Ray White. And it draws that text. Congrats, you created your first window, as you can see, in 190, so 190 pixels in X, and then 200 in the Y, and 20 font size, well, of course, in pixels, and with the light gray color. Now I could change this. Let's say, for example, maybe Ray Red. Well, there's no Ray Red, apparently. What other stuff there is? Apparently, there's only Ray White. Well, maybe red. Yeah, there is a constant called red, apparently, and it's defined as this. C literal color. But yeah, you could also do it this way. You could just copy this here and put it here. And there you go. Now you set the red, the green, the blue, and the alpha. And each of these values are actually 1 byte, which means they go only from 0 to 255. Of course, an unsigned byte, so 8 bits, right? And basically where 255 would be full light, right? It would be red completely, like, and 0, the light would be turned off completely. If you go somewhere between in the middle, then, well, you're gonna have like a grayish color. Well, of course, if you set all of them to the same color, then you're gonna have like a black, like a grayscale color. Right, but anyways, whatever. And here the alpha, the actual opacity, is it transparent or not? So if this is 255, then it's opaque. If it's 0, then it's transparent. Otherwise, it's going to be somewhere in the middle, right? So now if I actually run this, it should be red in the background. There you go. If I actually change this to some other thing here too, like I could go with, let's say, green, maybe. And there you go, I changed it to green. I could change the font size. Maybe let's say 64. That's too big probably. But yeah, there we go. And I could also change the text. There we go. I could change the position, like let's say 0, 0, that would be the top right corner of the screen, or should I say the window. There we go. Now we actually have left 1 pixel for some reason, but anyways, but yeah, you got the point, right? And you just gotta make sure that you do this, you call or you use these functions, these drawing functions between begin drawing and end drawing. So we could actually slice this into some functions, right? Like we could have here a void init, right? Initialize function. This is not necessary, but just for like, you know, to make this a bit tidier, I guess. But like you could say init screen width, comma screen height, right? And then here we would pass in the screen width and height, so integer screen width and integer screen height. And what's up? Can be made static. Yeah, let's make that function static. and does not match rule. Okay, sure, rename. And what's up here? Add const, because we're not mutating that. And also here we got the title. And we got the FPS. We could also add these as parameters, or we could just keep them as hard-coded like that. Okay, what's the next thing? The next thing, let's say we can make a draw function. Static void draw function. And this draw function would basically, let's say, contain this stuff here. Right? And so instead of this, we would just say right now draw. There we go. Perfect. Oh yeah, and if your function doesn't actually get anything, you have to set it to void here. Otherwise something else would happen. But yeah, if it doesn't have any parameters, just set it to void, just like main function here. Anyways, so we got the draw function, and then before that you can also have an update function. This is where you do some game logic. Let's say static void update. Now these functions aren't necessary, but you just to kind of like slice up our program into multiple functions here. But anyways, so that's basically it. Now let's check out some more sophisticated example in Raylib. And that's exactly how you're gonna like learn more about a library. You would just check out the examples. Now usually you wouldn't have like a website like this where you have all the examples and stuff like that. You would usually just have a Raylib, like, well, not Raylib, but like a GitHub directory, well, a GitHub repo of the library, and you would have an examples folder. Now one other thing that to note is the fact that depends on the like the version of the library that you're using. Now in my case, I'm using that Nugget thing. So which version I'm using? I'm using version 5.0.0. Now this is something that could trip you up. If you check out the examples here, you're gonna actually find another version, which is the latest version. Now to make sure you have the same version, you go to the tags here and you go to 5.0. Okay, which is the one that I'm actually using here, as you can see. And now I'm gonna make sure to have the same source code, the same example, the same everything, right? And right now here I have all the examples. I could check them out, right? But yeah, let's just use, I guess, the examples here anyways. So let's see if there's something interesting here that we could do. I guess maybe I would go. Which one should we make? So this is a very interesting program. We could make like mouse painting, especially that I have my. Why this? Oh, why this doesn't work, huh? That's interesting. Yeah, my pen doesn't work with this for some reason, which is very interesting. Arrow key scrolling disabled, huh? But yeah, as you can see, this is how it works here. So we could actually try to implement this, why not? And yeah, let's see. So I'm gonna go through all of this. So first of all, we got this colors thing. So this is like basically the colors bar here that we have there. And what else? We define color rex data for every rectangle. I guess let's just ignore this tools for now. Let's just focus on how we could like draw, like while the mouse is moving, we can draw, you know, these kind of circles around. Let's see where that logic happens. So let's go to the update function. So here in the update we're getting the mouse position. And in fact, let's see what we got here. So we could do something about that here. So in the update function, we're gonna get the mouse position. Hold on. So vector2 mouse position is equal to get mouse position. There you go. And now I'm gonna get a vector 2, which is just an x and a y value. Perfect. Now what's next? I could just like print this, or we could make it so we use this mouse position for the Codotaku text here, for example. So we could go with mouse position dot x and mouse position dot y. Now the problem with this is that you're gonna notice that this is not, it's indefined, it doesn't know it, because this variable is only accessible in this particular scope, in the scope where it's defined. So like when you come here, this variable would be added to the stack. You could search more about the stack in, like you could Google about it, right? And then when we're done with the function, when we're done with it, it just like goes away. Everything that is, all the variables that are defined in here would just vanish basically. And they would be replaced by other functions and so on, because that's what a stack is for. But anyways, so how we could actually fix this. Now, one way to fix this is to make a global variable. And honestly, I don't even know how to make a global variable because I've never done it since a long time. Let's see. Well, let's say vector 2 mouse position, I guess. Is that how it goes? Global narrow conversion from float to int. Okay, I guess that makes sense. That works maybe. And we just set the mouse position here. Now the problem here is that this draw text would want to take an integer, but we're getting a float. So we need to cast it, right? So let's cast that integer into, sorry, that float into an integer, and same thing here. And let's see if this works. And right now, notice that this text is actually, you know, following my mouse around, which is very interesting. Okay, perfect. Now that's one way to go about it. Another way, if you wanna like not have any global variables, we could make a struct, right? So we could have type def struct, and you could call it whichever you want. Let's call it application, for example, or game, or whatever. Let's call it game, why not? And then here we're gonna have the mouse position, so we're gonna store it there instead, right? And now instead of doing this, we're gonna say game.mouseposition.x and game.mouseposition.y. The problem though here, let's just call it g. Damn. Anyways, void, well, instead of void right now, we're gonna take a pointer to a game. We don't want to take a copy, otherwise we can't really, you know, change stuff there. It would make a copy, right? But yeah, there we go. Well, let's call it g, as I said. And of course we actually gotta use this because it's a pointer. Perfect. Now here we also need the game pointer, and we're gonna say g mouse position is equal to get mouse position. And now we gotta create that game object, right? So let's just say game g is equal to that. We're just gonna initialize it with nothing, zeros, right? And then we could pass it into the update function and to the draw function. Now one thing to note here is where I actually did that, where I actually initialized this game object. I initialized it outside of the loop. Otherwise, if I did it here, what's going to happen is that I'm going to create a new game object every frame, every image. And so anything, any data that I have like changed in this game object before in the other frames would be discarded, like basically. But if I want them to stay around, then I actually have to create outside of the loop, right? So yeah. All right, perfect. Now this should also work just the same way as it did before. Add constant here. And where else? Yeah, that's pretty good. Okay. It should work the exact same now, just instead of using global variables, which are usually not wanted, we use a struct. Okay, what's next? Let's see what we could do. Change brush size. We could just hard code those for now. Now let's check out the actual real logic that is happening here. So there's an S is mouse button down function, which we can use to check out if the mouse is down or not. So we could go here, and let's just remove this draw text Codotaku for now. Yeah, let's say if is mouse button down. And now what's this function takes? This function takes an integer value. And that integer value, we could get it from a constant like mouse button right here. Mouse button. And look at that. This is all the constants that are here. So like mouse button left. And now let's just say printf for now, I guess. Or we could actually just set, like, draw some circle here. Hold on. Draw circle. And now here we need the center X of the circle. Let's use our mouse position, g.mouseposition.x and g.mouseposition.y. And the radius of the circle, let's just say, I don't know, 32 maybe. The color, let's just say maybe black. And what's up? Oh yeah, this is basically wanting an integer, but mouse position is a float. So let's make sure to cast this like that to convert the type. And let's go. So now we're basically saying every frame, what we're drawing is if the mouse button down left is down, right? Then we draw a circle in the mouse position. And there we go. Now when I'm actually clicking, this is what happens. I get this kind of thing. It's pretty sick. Though probably Ray White would be nicer with the the red background. White. Did I just forget how to spell it? Interesting. Anyways. And yeah, it works also with my pen here, which is cool. Now let's check out the other logic. Else draw circle, get mouse, X draw circle lines. Okay. Draw rectangle, draw line. Draw rectangle rec. Now, how does it actually keep around those circles though? I don't really see how it does it. I mean, I could implement it myself, but I want to know how it does it itself. So, begin drawing, draw texture rect. Target.texture. Target, create a rendered. Okay, so they're actually creating another image that would basically can be kept around, because here, like the actual window, we clear it every frame, so everything gets reset, right? But we can actually create another image which we can do our drawing in, and that image we wouldn't clear it basically. So let's actually do that. So let's add a render target here, I think. Render texture it's called apparently. And probably FBO for texture. Which one should I use? 2D apparently. So render texture 2D canvas. Right, and here what we're gonna do is we need to first of all initialize it by creating it. And here we could actually open this. We could use designated initializers if we just do it like that. And now I could say dot canvas is equal to Lloyd render texture screen width screen height. Lloyd render texture screen width and screen height. Well, comma here apparently. So what this does exactly, it loads texture for rendering a frame buffer. Okay, cool. So it kind of like we create an intermediate image here that we can draw into. Now, how can I draw into that? I think that's a real question. Clear render texture before entering the game loop. Okay, so apparently we need to clear it before entering the game loop. Okay, so we do that by, of course, I'm gonna do that once before, like when the game starts, before we reach the loop. So we're gonna say begin texture mode, g.canvas, right? And then of course anything that begins should end in texture mode. And here I could do whichever I want with the texture. So this begin drawing to a render text. So basically right now, any of these draw functions that I use here would be applied on the texture itself, this canvas, not on the screen basically. I mean, in fact, well, yeah, anyways, let's just like clear this right now, clear the background with, let's say, I don't know, white for now, maybe. Alrighty, so until now, I think we're good. Cool, but we need to copy this texture right now into our screen. How are we gonna do that? Let's see. This would probably be called copy or something like that, I guess. Or draw texture. Maybe draw texture. Yeah, there you go. Draw texture. Rec. So let's use draw texture here. I'm gonna comment this out for now. And I'm just gonna say draw texture. And I have actually multiple versions of this functions, each with different parameters basically, but let's just look for the first one and see if that's enough. So it needs the texture first of all, which is our g.texture, or .canvas, sorry. And now position x, let's just go with 0, 0. And the color tint, we're just gonna go with white because we don't want to change the color at all. And if you set the tint as white, it's not gonna change the color. Okay, what's going on right now here? What's the problem with this? Cannot convert L value of type const render texture 2D to parameter type texture 2D. Huh, really? Oh yeah, because it doesn't contain just that, it also contains texture, a depth, and an ID. So let's go with the texture is what we want here. Alrighty. So right now we should be copying or drawing that texture, and there you go. Now the window actually was white if you remember, but here it's actually red. And to show you that's exactly the case, we could, like, let's say make the canvas smaller by twice the size. So we could divide by 2 here. Well, divide by 2. Divide by 2. So it would be smaller than the window twice. Basically half the size. And there you go. Notice what we have. We have our render texture here being copied over, and then our window, which is being cleared to black, I guess. Well, it's not being cleared at all apparently. But if I add this clear background again, look at that. It's actually red, and here's our texture. But in my case, for now, I think I'm just gonna leave it as full screen texture. Whoops. Full screen texture like this. And what else do I want? All right, so right now I could actually make use of that texture. Let's just like incomment this code right here, not the clear background, because if we clear, we lose all the colors and stuff that is there, all the contents of that image. And of course, before that, we have to say begin texture mode, G canvas. So we could actually draw to that canvas. All right, just like that. Begin texture mode, and we're gonna end it here. So after that, any draw functions would be, so in this case, draw texture would be done on the window canvas, not the canvas here. So yeah, hopefully that makes sense. All right, right now this should work. Oh, huh. Well, let's actually make it red, because I think we're we're actually drawing those as white. Yeah, there we go. So let's make that red. Why not? Where is it? There we go. And what? Okay. So I mean, yeah, we're getting something right now, but this is very strange. Look at that. So if you notice here, the X value is actually correct, but the Y value is reversed. Look at that. Interesting. It's because OpenGL textures are reversed. I see. So how we could fix that though? There you go. Render texture must be Y flipped due to default OpenGL coordinates. Interesting. Well, here they're actually using a rec. Now let's actually see the other versions that we have. And I think the best way to do that in Raylib is to just go to their website and go to this cheat sheet right here. And here you could find all the functions. Or honestly, you could even just go to here in your IDE and look for, where is it? Draw texture, hold control and click on that. And you can find the other functions near it, basically near it. So we have draw texture V. This one takes a vector 2 position instead of integer, which is great because here I actually do have a vector 2. So instead of having to pass both one by one, I can actually use that. So in the case of draw circle, do I have that though here? Yeah, draw circle V, apparently. That's the version that I want here. So instead of this, I could say draw circle V, and now I don't have to do this. I can just directly pass in the mouse position. There you go, that's cool. Alrighty. What's next? Now draw texture. I have draw texture V, which basically is vector 2 here. Now draw texture X with extended parameters. X here stands for extended. Right, so basically the same exact arguments here and the same argument here. The added arguments are rotation and scale. I could actually set the rotation and the scale. Now scale is kind of what I want, but not exactly, because this would actually scale the whole thing. It would also scale the x-axis, but I want to only scale the y-axis to invert it. So what else? We have the draw texture rec, which is actually being used there. And we have the draw texture pro and the draw texture in patch. So let's just try to use rec, which basically takes a rectangle as the source. As the source. And then a position. Okay, so just an extra rectangle there, basically. Okay, cool. Let's try to do that. Draw texture rec. And how do I do this? So I need to make a rec here, rectangle, and let's see how we're gonna do that. What the heck happened there? What's the problem? Oh, it takes a vector 2 here, so let's say whoops. Vector 2, same thing here. We're gonna create a new vector 2 object. We're just gonna set all the fields to 0. All the fields to 0 for now. Now the rectangle here, I'm not sure what they want me to do there. Let's see. So the x and the y of the source, and then the width and the height. Okay, sure. So 0, 0, comma, the width would be the game. Well, I could just get the width and the height directly here, in fact, if I want to. I could just say integer width is equal to get window. Oh, how do you get the window size? You can't, really. That's kind of strange. I don't think you probably can. Oh yeah, get screen width, apparently it's called. Int width and integer height is equal to get screen height here. Oh, but hold on a second. I need to make sure to recreate this canvas if the screen, or should I say the window, is resized. But let's not think about that for now. Let's just go on and use this width and height into float. Okay, and for these we could make them constant, and here let's make these into integer, I think. And what the heck is wrong with you? I don't know. Now we're in conversion from integer to float. Well, anyways, let's just run this. And now this should be the exact same thing as we had before. And by the way, I don't need this one. But right now I could actually change these fields however I want, which is nice. So in my case, I want to invert the y coordinates of this canvas. So just say minus height, I think. And let's try to run this. And now it actually works properly. Lovely. So we have made our first Paint program. Perfect. And I can't actually resize the window, as you can see here, which is interesting. But there you go. So we have basically created an intermediate texture or image which we can draw into, because basically we have to make sure to clear the window every time. Though actually here I'm not clearing it because I'm just copying the whole texture into the whole window. Though if that was different, like let's say the canvas is actually smaller, that I have to do something different. But yeah. All right, so I'm gonna take a little break, 5-minute break. If you have any questions, please let me know. So when I'm gonna get back, I'm gonna, answer them. Right. Alrighty, back. Let's go. Alright, perfect. So, what we had now is basically a little painting program. Now, let's say we need a way to actually change the brush size, right? How we could do that? We could make use of, and by the way, one thing that you're gonna notice here is that the more FPS we have, the better in this application. Where is the FPS? There we go, here. So if you go with, let's say 1 FPS for example, well actually that's too low. Let's say 10 FPS. If you say 10 FPS and I actually try to paint here, notice very little circles, right? But if I actually say maybe, I don't know, or like, can I actually even disable VSync? Let's see if I can disable VSync. Probably I would say 0 or something. Let's try 0 here. And that would be, it would basically try to like draw as much frames as possible. And there he goes. Now that's not great for the GPU. Oh, hold on. Mic on, okay. Now that's not great for the GPU because it would be trying to draw a frame, although the monitor can't really show it, but where is that thing? There we go, look at that. The GPU is, but actually that's not that much. Interesting. I'm not sure if this is really disabling the VSync though. Let me make sure it is. I mean, hold on. Is there like another function called VSync or something? There is a flag VSync hit apparently. So we could search about this actually. So we could search the VSync. And apparently this might I'm in demand for some reason. Anyways, VSync. What is it called? Raylib. Any way to turn on VSync? To make better full screen than standard toggle full screen, set the window size to monitor size. Raylib. Turn off VSync. Anyway to turn on, well, so maybe there's no VSync by default then. Can I actually get the FPS count? Oh yeah, I can, perfect. So let's try to print that then. Printf, or instead of printf we could even draw it as a text really. Let's actually do that for sure, why not? So like, let's draw some text here. So draw text. And the text is get FPS. Now the problem with this is that get FPS would give us an integer, but we need the string. So we basically need to convert the integer number, right? The integer into a series of characters. So I don't know how to actually do that. I don't remember. Let's say convert, maybe. Oops. Convert. Well, maybe text to. Okay, so there is an integer to text probably. Huh? No, there's text to integer, which is very interesting. What else there is? Text split, text to integer, maybe text from integer. No. Interesting. Raylib, integer to text. Oh yeah, there is a text format. I just remembered right now. So this is that's kind of like printf basically. So here what we could essentially do is text format, and then the format D because this is an integer. And then we could just pass in the FPS directly, honestly. I don't really need a variable for that. And oopsies. There you go. Let's remove this. Text format. Function has 5 parameters. Yeah. What are the other parameters? The position X, let's just say maybe 8 by 8 maybe. Font size, say 20. Color, let's say white or maybe yellow. Well, actually yellow, meh. I don't know, man. Let's just go with white, honestly, I don't care. Anyways, let's just do this. And look at that, that's the FPS right now that is running in, which is in. So we have like around 1000 FPS, right? So basically 1000 image per second if we set it to 0. Though what if we don't set that? Yeah, it's by default VSync off, right? Well, it's not even VSync really. VSync is actually a different thing. But anyways, we're just gonna keep that disabled because we want this to be as smooth as possible when it comes to drawing. I mean, we could actually make it smoother without increasing the frame rate, but this is a very simple way to do that. Alright, so what's next now? Let's maybe add some other stuff. Yeah, as I said, let's say we want to change the brush size. How we could do that? So integer brush size, and how can I do that? Brush size. Yeah, I need, let's say I want to use the mouse wheel to drive that. How I could do that? Let's see if there's a function mouse wheel. Yeah, there's a get mouse wheel move, and there's one for vector 2. Yeah, I'd like to get the vector 2 one, why not? And I'm basically gonna have, yeah, we already have a brush size, and I'm just gonna grab the Y axis of that, I think maybe. And now I'm gonna say G brush size is, well, G brush size is, you know, plus equal get mouse move v dot y. Cannot assign, well, let's say float, why not? And what's going on here? Cannot assign to read only type const float. Oh, because here we have a constant. And honestly, that makes sense. Let's not do this in the draw function. Let's do it in the update function, really. Brush size plus equal get mouse wheel, because basically the draw function should not really change the state of the game. It should be always constant, really. Well, kinda, but anyways, so that seems to be good enough maybe. Now, in fact, we're gonna start with brush size is equal to 32, and then instead of just here hard coding, where is it? The radius. Here we go. We're gonna use that brush size. So G brush size here. Now let's see if this actually work. Right now I'm actually using my mouse wheel, as you can see, and it actually does work, which is cool. Now one little problem with this is that I don't see my brush how big it is until I draw. One solution we could do is, instead of drawing into the canvas, we can draw into the window instead, right? We can draw the actual brush. So here's what I'm gonna do. So after drawing my texture here, I'm gonna also draw a circle again. But that circle would be drawn not into the texture, it would be drawn into the window. So it wouldn't persist. It would only be visible in one frame, as you can see. And there you go. Pretty cool, huh? Love that. Pretty sick. Now we still have that problem though. Now we could probably solve that. But yeah. I mean, should we do that though? I mean, basically we could store the old mouse position, right? Old mouse position. So basically the previous frame mouse position. And we could essentially say, G mouse position, get mouse position. And it's kind of like after we're done with all that, we need to set the... So basically what I'm thinking about is that after we're done, you have to set the old mouse position to the new mouse position. But then of course we can't have this as constant, I think, anymore. So yeah, because I want to do that after it's all done. But yeah, anyways, let's just run this. But in fact I didn't do anything yet, really didn't change much, so just prepared that one. Now what we want to do basically is here we want to use a for loop, right? We want to go from the old mouse position, well, vector to, is there a lerp? Hold on, is there a lerp function? Linear interpolation. Well, there's a color lerp in a header va defs. So maybe not. Raylib lerp. Or maybe I just have to do it on my own. Yeah, I don't really see anything there for that. Oh, there is a vector 2 lerp. There we go. That's but it's basically in raymath.h. So let's include raymath.h. Include raymath.h. And that would give me some extra functions for mathematics, right? And one of them is lerp. Let's see how we're gonna do this. So we're gonna say for loop, and the lerp function takes a float amount, which probably goes from 0 to 1. So we're gonna go and say, well, we don't want to use a float in a for loop because, well, a floating point is not precise. So we're just going to use an integer, okay? You're going to say I is equal to 0 and up to some certain steps, right? Sub-steps. Let's say, for example, 100 circles every frame, for example, and then I++. And then what we're going to do is we're going to get some alpha. Now the alpha would be a float. It would be an I divided by this amount of samples. We usually call these kind of things samples. 100 less than samples. So this would basically be a value between 0 and 1. 0 at the start of the loop and 1 at the end of it, right? That's basically the case here. And here what's going on. Let's turn this into float and this also to float because that's a float, right? Perfect. And this is a constant value. Now the alpha, we could use it to lerp between the two positions, between the old mouse position in the old frame and the new mouse position. So we could say draw, well, let's actually grab that draw circle here, I think. Whoops, and put it here. And we need the new, let's calculate the position. Vector 2 position is equal to vector 2 lerp, the old mouse position, and the new mouse position. And here, so basically what lerp does is that you give it an amount which is between 0 and 1. If that amount is 0, then it's gonna give us old mouse, it's gonna give us the first vector. If it's 1, it's gonna give us the second vector. If it's 0.5, it would give us the middle point between these two vectors, and so on, right? So like, let's say 0.1, it would be 10% of the way from this old mouse position to mouse position. So here what I'm basically doing, I'm using this loop to go increment 1 by 1, like I'm doing 100 steps from old mouse position to the new mouse position, essentially. And I'm gonna draw a circle so I can make it basically smoother, right? Because I'm gonna be drawing more circles every frame instead of just one. And I'm going to be drawing it from the old mouse position to the new mouse position. So here I'm just going to use my alpha here. Alpha male, alright. Okay. Add constant. And let's actually run this. And let's see. Now, it should be way smoother, I guess. But I can't really notice though. Maybe if I made it like much less FPS, then maybe I would notice more. Let's see. Mouse position. How I'm gonna do that? Yeah, that's the target FPS thing, right? Let's say 10 FPS, for example, I think. Actually, I don't see 100 circles there. That's interesting. I don't think those are 100 circles. That's kind of strange. So something is weird here. What I could do is to simply debug this and see what's happening here. Notice that the alpha would increment every time. Okay. Then we're lerping between old mouse position and mouse position, but since I'm debugging, it was actually the same thing. Well, you know what? Let's actually print the difference in the mouse position. So let's print f, I guess, d comma d, and we could print the difference basically. So like vector 2 d is equal to g old, well, mouse, well, hold on, vector 2 well, add sub, probably subtract, and you have the v1, which is going to be the mouse, old mouse, well, actually the mouse position, and then we're going to subtract old mouse position. And let's see how we could even get how big is that, in fact. So we could get it by getting the length of the vector. So instead of just getting the x and the y components, we could just get the length, right? By saying vector 2, I would guess length. Yeah, there you go. And let's just grab the length there. Oopsies, well, this is going to be a float probably. And here, this should be f here, perfect. And honestly, I'll just merge these two things together to one variable. And it should be printing stuff now, cool. And it doesn't add a new line apparently. So let's add it and see. Now we should be printing the distance between the old, like the mouse position in the old frame and the new frame. And yeah, it's there. So I'm not sure why I don't notice the and in fact, I could even use that to actually, you know, set some samples here. So I could even go ahead and just say samples is equal to that. Really? Oh, I see why. I'm still using the mouse position instead of this new position. So that's exactly why, apparently. Now it should actually work perfectly. Now it should work perfectly. There we go. Now if we even have 10 FPS, it should still work kind of fine, I guess. Let's see, where can I set the FPS? Here, set target FPS, let's say 10 frames, and let's see. And look at that, even with 10 FPS it still works, though of course as you can see the path is less smoother because we're just doing a linear interpolation. Though we could even make it even smoother by, instead of doing linear interpolation, we could use quadratic interpolation, though I don't know if I want to go that advanced right now. Quadratic interpolation. Like, is there a Bezier function here or something like that? No. Okay, where's the lerp though? It's right here. So there's apparently no quadratic thing here or Bezier. Interesting. Let's check it out. Raylib Bezier. Okay, there is a cubic Bezier lines example apparently. Let's see what this uses exactly. And oh, we could actually set the config flex MSA, but I'm not using shapes like this though. But maybe I should. Anyways. Alright, so what we have here, draw line Bezier. But no, that's not exactly what I want. I don't want to draw a Bezier. I want to calculate a Bezier. So apparently there doesn't seem to be one, but we could just make it ourselves. In fact, I could even show you how you make the lerp. So like we could have a float lerp function, and it basically takes a float A and a float B. Well, in our case, we want to for a vector 2, right? Yeah, we do, but I mean, it's kind of the same thing. Hold on. Let's just say float A and float B. And then let's say float alpha or t. And then we could return b minus a times t. We could either do it this way or we could do it this way. A plus 1 minus b. What? No, hold on. No. Oh, I actually don't remember the other way. And by the way, this one should be a plus b minus a times t. Yeah. Okay. I don't really remember the other one. Yeah, I don't remember the other. But yeah, this is how you do it. This is the lerp. Now we could make a quad. I don't even remember what this is exactly called, but let's see. Float B, probably also float C, float T, and float. What should I even call this? Let's say D. Maybe. Lerp A from A to B, and I don't know, let's call this D1, D2, and from B to C. And of course the T here. And then we want to lerp those together. We're going to return lerp D1, D2, T. Now there is a very interesting animation video that you can look up. Freya, I think it's by Freya. Yeah, this one. This one would really explain what these lerps are about and all the stuff that I'm actually doing here. So really recommend watching it, because I don't want to waste too much time kind of explaining this. Yeah, there's also splines here which are interesting. So yeah. Alright. Let's search for lerp and see if I can find some actual quick examples here, like visualizations. Apparently doesn't seem like it. Though I could probably do it myself, but let's not waste time on that right now. Okay, add const in the whole project, please, or in the file. There you go. And what's wrong with this? Add the const, and oopsies, add the constant. And there we go. Cool. Now these are for floats. Let's actually do it for vec. So vector2. Now here I could even use my AI to actually auto-generate that stuff. Where is it? Hold on. Enable completions for C++. Because it's a very trivial job. There we go. As you can see, it auto-generated that stuff for me. And in fact, it just used vector2 lerp, basically. Is there like a lerp? Yeah, there is a lerp already, so I don't even need this. But it's good to know that you could actually do it that way. So, but we could just use here lerp directly. So, if you want. But honestly, we don't even need this really. We could just use this. So quad. And we don't need the AI anymore for now. As you can see, it's using vector2 lerp. Alright, perfect. Now, what I could basically do is instead of just recording the older mouse position, like the mouse position from the previous frame, I could even record the mouse position from the second previous frame. So like the old frame, no, but even before that, the older frame of the older frame, right? So how can I do this? What should I even call it? Vector2 second older mouse position, I guess. Second older mouse position. And now what should I do? Now here I should basically set the second older mouse position to G old mouse position. There we go. And now what? Now instead of doing a lerp here, well, where is the lerp? Vector2 lerp. Instead of doing that, I'm gonna actually use my quad here. So I'm gonna give it A, B, and C. A, B, and C. Hold on a second, what? Yeah, that makes sense. Alright, let's go ahead and say A would be... So the starting point, what it would be. Yeah, G older, second older mouse position. And the other one would be the old mouse position. So basically the second one, right in the middle one. And then C would be, so like the second one kind of like would be a control point. Interesting stuff. And the other one would be G mouse position, and finally T. Well, not T, I called it alpha, but yeah, doesn't matter. Okay. Now let's actually try this out. And what the heck is wrong with you? Calculate vector length. Cast from function call type float to non-matching type. That's strange. Anyways, whatever. Let's just try to run this, and my FPS is still 10, so it should work just fine, I guess. And look at that. So it's a bit smoother than before. So instead of a lerp, just like a regular linear interpolation, we actually have that. And it should be even smoother for the other, like for more, where is it? Let's say 60 FPS, let's try that. And there you go. Perfect. So let's actually make it small. Let's make the brush smaller first. That's pretty sick. Love that. Or we could even, like, instead of having a set target FPS, we could add a VSync. We could allow VSync, which would be better actually. Raylib, how do you do that? No, I don't think that's not the one. I do remember, yeah, flag VSync hint. Set config flags apparently, okay. So let's set those config flags. Let's go here to the initialize function. And here let's say set config flags and add in flag vsync hint. And now vsync would be turned on, and basically we would be, our window, our rendering would kind of like be, it would follow how much the monitor, like how much hertz the monitor has. Like in my case, I have a 75 hertz monitor, meaning my monitor can only display 75 images per second, so there's no need to actually render more than that. So if I make the vsync on, it would make sure to like sync the two, sync my rendering with the vsync, and so it would have a smoother refresh rate, right? But anyways, but yeah, there we go, perfect. Now maybe right now we could add, let's say, the palette for changing the color. Why not? Hopefully I didn't go through too much. I probably did, but like for these quad and lerp stuff, you could actually learn them from that video. It would be way better because it's an actual animation. It's a very, very well made animation. What else? Samples. This is not really, this is just kind of like a heuristic kind of thing, right? Not really accurate, especially for, maybe it was kind of accurate for the linear interpolation, but for the quad, no, it's not gonna be accurate, but it should be probably enough, maybe. But anyways, alrighty, let's see. Is there anything else that I didn't really explain here? I don't think so, because I did kind of get too fast there a bit. I'm trying to slow down, but yeah. So, okay, cool. What's next? All right, let's go to the, back to the example that we had before. And basically right now we want to draw some rectangles up there, up here, that we can use to change the colors, right? So first of all, we're gonna have like an array of colors inside of our game. So game colors, and is there like a color type? Apparently there is, I guess. And here, let's say, let's just have, I don't know, 3 colors maybe for now, or whichever. And let's just actually initialize them here. And let's say, say white, maybe green, blue. Okay. And now we have 3 colors there, and basically we want to draw a rectangle for each of those colors in a vertical, well, in a horizontal fashion, right? We could also do it vertical though, but yeah. All right, let's just, where I'm gonna do that. Of course, I don't want to draw inside of the canvas. I want to draw it just in the actual window. So how are we gonna do that? Let's see. Draw circle V. Okay, let's I guess do it here. So for loop, for integer I is equal to 0, I is less than the colors count, so size, well, is there a count of kind of function? I do remember there was a count of function. There we go, it's in stdlib.h. And we can see count of colors, so G colors. Now I'm not sure if it would work here. So let's see, I++. Because we don't have the colors array in the, I guess we'll find out. And actually let's say size T here. Yeah, and so for every color in the array, we're gonna draw a rectangle for it. So the position X, it would basically be I times some difference, let's say 100 for example. For the Y, let's just go 0 with, let's say 100 or a bit less. And the height, the color, now the color we're gonna get it from the array. So G colors I, and we're gonna use the index there to get that corresponding color. And now here what we got, who cares? So let's just do this. And there you go, perfect. So as you can see, we're drawing this rectangle, though they're actually too big though. Yeah, they're too big. Let's say maybe 32 here and 32. And now here, let's just say maybe 40. The position Y, let's also have maybe a bit of margin, like 8 pixels maybe. Let's see this. And let's actually add a plus some other margin here. Plus 8 in the X. And there you go, perfect. But we can't really detect the touch of this yet. So we have to also program that. Now what we basically want there is every time the mouse is down, the mouse button left is down, we gotta check if we're colliding with some color. If we are, and then we want to change the color, right? So how are we gonna do that? Well, we're gonna use that rect collision thing, I guess. Check collision rect. So this takes 2 rectangles apparently, but no, I just want a point or something. Oh, point rect apparently. So you give it a point, which is our mouse position. And our rect would be the color rect. Interesting. So, well, we could actually just maybe do it here, really. Like do it here. Let's actually first of all turn this into a rectangle, really. So this would become easier. So let's use the rect version of this. And we basically have to construct a rectangle now. Flow X, Y, width, and height. So the X is basically this. Oops. What the heck happened there? This is the X. I times 40. What happened here? That's strange, man. But it's called with 1 argument. Oh, I guess that's fine actually. Why? So 8 pixels there, and the width is 32 and the height 32. And that's it basically for there, and the colors is G colors I. There we go. So I'm just gonna remove this now. Now I have this rectangle which I could put in a variable rectangle rec is equal to this, and this probably could be constant, yeah. And yeah, that's basically, I think, it here. Right now we're just gonna have the exact same thing we had before, but right now we're using the other version which takes a rectangle instead of separate, you know, things. Now it can just basically check if we have collision. Well, first of all, if is mouse button down, mouse button left, right? Now, if it's down, then we want to check the collision with this rectangle. Let's see. Honestly, I don't want to do it this way. I want to separate this. Yeah, I want to separate that. But yeah, fine. Let's just do it like this for now. If check rect, collision point rect, right? Now the point is G mouse position with the rectangle of that color box, right? The rectangle of that color button, basically. So there's no like button here in Raylib, but basically we're just drawing a rectangle and checking the collision of that rectangle with the mouse to make our own button, basically. So yeah. And now if we have collision between the mouse and that rectangle, that means the user wants to select this particular color. So for that, we're actually gonna have like a brush color here, brush color, and we're gonna use that. So in this draw circle V, we're gonna use that. So G brush color, same thing with the other one here, G brush color, and there we go. Now if check collision, we're gonna say G brush color is equal to this particular color. So G color is I, and this should probably work. Let's see. And oh, what? Probably it should be black by default because it's zeros. That's interesting. But brush color. So was it white? Yeah. Let's see if that works. Yeah, there we go. Now if I actually click on this one, there we go. Like this, there we go. Now let's say we actually want to save this canvas that the user drew into a file. How we can do that using Raylib? Well, we do have a texture. We need to find out if Raylib have like a save texture function, which I would guess it does. Let's see. Save, but this is for Raymath cheat sheet. Let's go to the old, well, hold on, let me go to the main cheat sheet, I guess. And let's look for, what is it called? Save texture, I think, or something like that. Doesn't seem like it. Huh, interesting. Where are the texture functions here? Well, okay, well, we can load an image from a texture apparently, which is interesting. There's a way to make the next thing. Exactly. Adam Govoni, welcome to the live stream. Alright, so until now we actually haven't really introduced that much C concepts really, but you're learning more about, you know, logic, how to implement some logic stuff in general, right? Kind of like algorithms, but whatever. Anyway, load image, export image to data file. So we could load images, but what about saving images? Is it that exports? Yeah, basically exports image. Now I need to figure out how can I get an image from a texture. Yeah, Lloyd image from texture. There we go. Lloyd image. And by the way, the difference between a texture and an image is that an image is in the CPU. It's stored like, not CPU, well, stored in your system memory, RAM, right? But your textures are actually stored in the GPU memory. So your graphics card memory, which is called the VRAM, the video memory, right? So yeah. So basically we need to get it from the GPU memory to the system memory to the RAM, from the VRAM to the RAM, and then we could save it using this export image function. So I guess let's do that. Now let's say we want to, like, when you click Control S, that happens. How are we gonna do that? Let's check if there is like, if it's key down or something like that. Is key, yeah, there is, there we go. Is key down or is key pressed? We could go with is key pressed. Yeah, alright, so let's do that in the update function, I guess. In fact, some of this, like the check collision, should probably go to the update function, should be separated into the update function, because it doesn't have anything to do with the rendering except that it have the same rectangle here, but we could just recalculate that. But yeah, now notice that, well, honestly, never mind, let's not go into details on that. Anyways, so what I wanted, yeah, let's actually check if it's key pressed. So the key, how we can get the key. So there's some actual constants here apparently. So key S. And so to do an and, you do like this, right? Is key pressed. Now we need the control. Is there control here or something? There's a left control or right control. Okay, let's go with left control. Now, if both of these keys are pressed, then we want to save the actual texture. First of all, we need to get the image from it. So image is equal to Lloyd image from texture, G canvas, I think, right? Or no? Well, dot texture. There we go. And the next thing, we need to actually export that image. Image, comma the file name. Well, I guess let's call it canvas.png. Now we could make a dialog and so on, but right now I just hard code this. And if we run this right now, and let me actually open up this in File Explorer so I could see the files here. I'm not sure exactly where it's gonna put it though, but we'll see, I guess. So let's just draw something here. Let's say Control S. And where did it put it though? Good question, I don't know. Well, it doesn't seem like it. I'm not sure if this is actually working, but let's just do some printf stuff here, please. Printf saves. Curious, do these functions already exist in C, or did you have to make them earlier in this code? For example, the is key pressed. No, we have, like, if you check the start of this stream, I have shown you how, like, to actually install a library called Raylib, which gives you all of these functions. And like, it gives you functions to draw, to create a window, and some other like math functions, etc. But yeah, all the functions that are here that are not from C, they're from Raylib, basically. So yeah, so like, is key press that you mentioned is actually from Raylib. So yeah. Right, printf here, what we want to print. Yeah, the image saved, I guess, or canvas saved or something. Let's actually see when that happens. If that happens or not. So now I actually press Ctrl S, but it doesn't really show anything apparently, which is very interesting. Why? Why? Well, then I guess let's actually printf these two. That gives the boolean basically. So let's printf. Well, what the d comma d, and I'm just gonna print these two here and see what's up. Oops, let's add a new line there. Control S. I guess maybe they never happen in the same frame, I would guess. Probably not, yeah. That's probably why. Interesting. So if I actually do yeah, that's probably the case. So how would I fix this? Good question. So I would guess maybe here Raylib can't really detect both keys getting pressed at the same frame maybe, or something like that, which is very interesting. So let's actually search this up. Raylib, well, these keys are actually called modifier keys though. Modifier keys. Those Control, Alt, etc. they're called modifier keys. And let's see, key position based, detecting Windows keys, key pressed. I don't think this is related to what I want here, but Raylib detects multiple keys pressed. Nah, that's JavaScript. Huh, then this is very strange. You know what? Why I'm overcomplicating this stuff? Let's just go with S anyway. Let's just go with one key, which is S, honestly. Yeah, why not? Let's just go with that for now. And that should work now. Let's see. So, boom. Now S, and look at that, file saved successfully. So now let's see where we can actually find this. Okay, where is that thing? Open folder, there we go. And canvas.png. And there we go. We have saved it. Pretty cool, huh? Love that. Now let's say we want to load it though. So let's detect like files when we actually drop some files into the window, and then we could load them. So how we could do that is, I believe there's some API in Raylib 2 for that. Some functions for that. Let's see. Dropped. There you go. So there's some file system functions here. So is file drop, check if a file has been dropped into a window. Then we could load those dropped files and load them and get file mod time. Okay. So let's actually do that. So in the update function, we're gonna check if there is some file got dropped. So this is file dropped. Then we have some file dropped in this frame. So let's actually load them. So file path list files is equal to load dropped files. And now this file path list contains a capacity, a count, and the path. So we basically gotta go through all those files using a loop. So for integer I is equal to 0, and then I is less than files dot count, and then I plus plus. And then here what I'm gonna do, here I need to load that file. Right, files. So the path, what kind of path it gives me? I think a string probably. So char pointer path is equal to, let's see, files dot path I. So here basically we could even drop multiple files at once. But honestly that doesn't really make any sense in my case. Really, yeah, true. So I could just get the first file. Or, yeah, I'll just get the first file. But anyways, let's get that, I guess. So how I'm gonna do this. File is equal to, well, char pointer path, actually path is equal to files 0, isn't it? Well, path 0, there you go. And now this could probably be console, I guess, but hold on, let's make sure to enload the dropped files, because that load dropped files function actually allocates memory, and if you don't enload them, then it's gonna, you know, like you're gonna have a memory leak, which means that it's like every time there's a file that gets dropped, you're gonna allocate some memory here, but you're never gonna free it. So with time, you're gonna keep on piling up some memory that you're not using anymore, right? So you're not gonna be able to access this memory anymore because it's gonna go out of scope. You're gonna lose the pointer to it, right? But it's still gonna be there, it's still gonna be allocated, so you're still reserving it essentially, but you're not using it, and that memory would keep on growing, and at some point you could like reach a limit, right, where your application would crash, right, by the OS. Anyways, let's unload this dropped files and give it this, right? Yeah, pretty much. Let's actually add columns. Honestly, I haven't covered much about the heap, like how to allocate memory and stuff and files, but maybe next stream I'm gonna cover those more advanced details. But I just too simply didn't really need them here, especially thanks to Raylib. Raylib is really good in hiding a lot of complexity and making C very usable, especially for beginners. So as you can see, I didn't really use any really advanced like C stuff, right, or C concepts. There's not even a lot of pointers, and that's by the design of Raylib library. So yeah, some more advanced libraries would actually go crazy about that, but yeah, they just have two kind of different goals, right? So Raylib have the goal of actually being friendly to beginners and being simple to use, while other libraries could focus more on performance, let's say, and more on efficiency and advanced use cases, basically. Because when it comes to software, like as a software engineer, you're gonna have to choose between, a lot of times you're gonna have to choose between performance, ease of use, and what else? Also code size, and what else? Yeah, I think that's basically, well, at least the most basic ones are these, the ones that I can actually remember for now. But yeah, also disk size, choosing between the disk and the RAM. There's a lot of actual factors, yeah. But anyway, that's why it's actually quite important when you start a new project. You need to think about your use cases. You need to set some goals. Like, are you, let's say, focusing on performance, or are you focusing more on like ease of use, simplicity, or what exactly are you focusing on? Or flexibility? Or what? Anyways, so is file dropped? Then we unload the files. All right, perfect. Now, after we get the path here, we want to load it. How we can do that? Load image, I think. Yeah, and then you give it a file name, which we could just give it the path here. And then what? We load the image, and then so I guess that would probably give me the image that I loaded. Correct? Yes, pretty much. Now we loaded this image into memory, into RAM, right? As you can see, load image from file into CPU memory, RAM. Now we need to load it into VRAM as a canvas. So how are we gonna do that? Well. Now there's two ways we could do this. We could create a whole new canvas altogether, or we could just draw this image into that canvas. Either way, we're gonna need to actually, hold on, let me just see what functions I have here. Yeah, I don't have draw image, that's for sure. So I gotta create a texture anyway. Let's actually do that. So load texture from image, and then I give it the image, and then I don't need that image anymore, so I should unload it. Otherwise it's gonna be leaked, its memory will be leaked, right? You gotta make sure to unload stuff that you don't need anymore. I could have easily forgot about that. Now newer languages like Rust and so on, they have features to actually make this a bit automatic, right? Using smart pointers and so on. And C++ too. So C++ have a concept called RAII that you could check out. Rust, kind of a similar concept too, but let's not go into those details right now. All right, so since I made the texture, I don't need the image anymore, so I just unload it. And now, as I said, there's two ways. We could either create a new canvas, or honestly better it would just to like begin texture mode on this. Now we kind of sucks because like we're gonna be doing kind of drawing into the update function, but anyways, who cares? So G canvas, and we're gonna end the texture mode here. Do we actually have to do begin draw, right? I think we, or do we? Maybe not. Oh yeah, we do, because we have begin drawing here. I see. So you have to first of all begin drawing, I guess, and then end drawing here. And then basically I'm gonna draw that image, or should I say that texture. Whoops, draw texture. So our image, well, not image, texture, sorry, and then position X, let's just go to 0, 0, and the color white. And there we go. Whoops, add const. And after that, I'm not gonna need that texture anymore, so let's unload it too. And there we go. And notice one thing about unloading stuff is that whatever you load first, you should unload last. Just as a rule, you know. Though sometimes it doesn't matter. Like here, it doesn't really matter if I unload texture or dropped files first. But just as a consistent way of doing it. Because if those resources depend on each other, then that's the way you gotta do it. But, you know. So just save yourself the hassle and just do it anyway, even if they don't depend on each other, basically. So now I could probably right now get any PNG and put it into here. And let's see. Okay, I have my PNG here. And look at that. There we go. And I could draw stuff here as I want. Right. Yeah. And just say S. And right now I actually got my image here. And yeah, we have made all of this stuff in a few lines of code, in over 24 lines of code. It's we didn't really use anything very advanced. Whoops, what I've done there. Let's see. Open folder, file explorer, canvas.png, and there you go. Oh, though we have a little problem here. The image gets exported flipped, right? Interestingly. So we gotta flip it before we export it, apparently. I would have not noticed if we didn't have a more sophisticated image. Alright, well. Well, stuff like this happens a lot. So you gotta do more testing. Okay, so how can I actually do that though? In fact, did it even get loaded correctly in the first place? Yes, it did. Alright. So never mind, let's see. Where we do the saving, here we go. Load image from texture. And then we could just, I guess, flip the image or something. Yeah, there we go, image flip vertical. And then we could give it the image. And apparently I need a pointer, I guess. Or what do I need exactly here? Yeah, pointer to an image. So what the heck is wrong with you? Okay, so that can't be constant anymore. And let's go. Now we could actually do that again. Pictures. Let's grab this for example. Other thumbnail here. Let's add some touches there, right? And then let's just save this as. And there you go. Canvas.png, and look at that, right now it's actually correct, it's flipped, perfect. And yeah, that's a lot of cool stuff that we've added. There is a lot more to add. Like we could keep on adding features here until the morning. But yeah, I think I should probably finish the stream at this point. Yeah, already 2 hours and a half. So is there any questions? Please let me know before we end the stream. I'm probably gonna stream again tomorrow to continue. Tomorrow I think we're probably gonna go with some more advanced concepts like the heap. And I may make a matrix object, like kind of like a matrix library thing. So yeah. All right, let me see. All right, so thanks for Loop Luminary, Woji Girin, Robert, Fanzel Romanizi, hopefully I didn't butcher the name, Theo Paris, Eileen, Codotaku, of course, and Adam Govoni. Thank you all for coming to the stream. and see you later, guys. Goodbye, everyone.